This is going to be a video on how to draw ray diagrams. I'm just starting with a picture of all the parts of a diagram. So the lens is here in the center. The line that goes straight through is the principal axis. Alright, so all of these things will be a part of every diagram. You have a focal point labeled here and a focal point labeled here, and this is then the focal length from the center of the lens out to that point. You have the object that you're going to make an image of. Right? You always just draw that as an arrow. And then this distance from the center of the lens to the object is the object distance. The height here is the object height. And then you'll use rays. You'll draw the rays of light coming off the object to figure out where the image is. The three rays that we'll draw for every one is, one will go in parallel, meaning parallel to the principal axis, and then out of the lens through F2. The other one will go in through F1 and out parallel, so it's just the opposite of the first one. And then the third one is going to go straight through from the top of the object through the center of the lens. Where all three of those rays meet, that's where the image is going to be. Okay, so let's start with an example. So here I have a converging lens with a focal length of 4 squares, an object distance of 10 squares, and an object height of 3 squares. Now instead of drawing the whole lens, I'm just drawing the center line of the lens, and then these pointy arrows at the top indicate that it's a converging lens. And all of these diagrams are going to be with converging lenses. So essentially, instead of drawing that whole curved lens there, we're taking and just looking at this center line so that we don't have to draw the whole lens. Okay, so that's what our lenses will look like in our diagrams. So, the 3 rays that I need to draw. The first one goes in parallel and out through F2. So my focal length is 4 squares, so I put F1, 1, 2, 3, 4 squares away. And then F2 is on the other side, the same thing, 4 squares away. So I draw my ray. It goes in parallel and out through F2. Okay, so the light reflecting off the object here goes into the lens and then refracts towards the focal point. My other ray then, if the light reflecting off the object comes into the lens at an angle through the focal point, then the opposite will happen. It will come out parallel. And you see I already have a place where those two meet. But I'm going to go ahead and draw my third line to make sure everything is making sense. So the light reflecting off the top of the object through the center, unrefracted, goes straight through. And I end up with right here, right there is where my image is. Now I'm going to say some things about the image. The image is inverted. Right? The tip of the arrow is now below the principal axis, whereas the object, the tip of the arrow started above the principal axis, so it's upside down, or inverted. It's smaller. And because it's over here on this side of the lens, the opposite side of the object, I know that it's real. Right? Meaning that it's actually projected onto this side. Now we can be more detailed. We can actually talk about the object distance being 10 squares and the image distance, the distance for the image being 1, 2, 3, 4, 5, 6, just over 6.5 squares. Let's say maybe 6.6 squares. The object height, the image height is now only 2 squares. Right, so it's smaller. It started out as 3 squares. Okay, so that's how our ray diagrams, every single one will be drawn that way. In parallel, out through F2. In through F1, out parallel. And then the third one just straight through the center. Okay, so let's do another example and see what happens if the converging lens is close to my object. So here I have a converging lens with a focal length of 5 squares. So 1, 2, 3, 4, 5. There's my focal length. Put a focal point there. 1, 2, 3, 4, 5. Put a focal point there. Right? And now my 3 rays. In parallel, out through F2, right? The other one, in through F1 and out parallel. Well, F1 is over here, so that's going to make things tricky, right? So if it's coming in as if it's coming from F1, it's going to happen up here. Let me just go ahead and draw the third ray, though, before we get into that second one. The third ray that just goes straight through the center. Looks like that. These lines are never going to come together. Right? Like the other picture, the lines actually all met at one place, and that's where my image was. But for these, they don't all meet at one place. The last line that I'm going to draw then, and it starts to be more tricky, but it comes into the lens as if it's coming from F1. And then it goes out parallel. Okay, so it's inside the focal length. So this line actually comes up this way, whereas in the other one, the image, the object was out here and it went down through F1 and out parallel. Here it's coming up from F1 and out parallel. So if I'm here on the other side of the lens, looking through the lens, all of these rays of light appear to be coming from someplace back here. These rays appear to be coming from behind the lens, like this. Right? And this one appears to be coming from behind the lens, like this. And this one appears to be coming from back here. Like that. So the image appears to be right here. So this is my image. The image is upright. The image is bigger. And then think to yourself, is this image real or virtual? It's virtual because I'm looking through the lens to see it back here on the other side. The other way to know that it's virtual is that it's upright. All real images will be flipped upside down. Okay, so those are our 2 examples of ray diagrams with converging lenses. When it's a real image, the picture will look like that. Where the first ray that comes in parallel and out through F2, the other one in through F1 down here, out parallel, and then straight through the center. It gets a little bit more complicated when I put my object inside, right? Here's my object. When I put it inside the focal length, that second ray gets complicated is coming from behind. Here's my f1 up to the lens, out parallel. And then I look to where these three diverging lines appear to be coming from. And that's my image. So I'm going to draw a couple more. Okay, let's watch one more get drawn. So, my three rays. First one in parallel and out through F2. Parallel, out through F2. The other one, because I'm outside the focal length, this one's going to be more like the first one that we drew. In through F1 and out parallel. And you see I already start to see where my image is forming. But draw the third one, just to be sure. And all three of them, all three of them end up meeting at that same point. So there's my image. It's inverted. It's bigger or magnified, and it's real because it's projected onto the other side and upside down. I can look at some of the actual measurements. My image distance, if you count, is 12 squares. My image height, if you count, is 6 squares. Okay, so this is my image over here, starting with an object 3 squares tall, an object distance of 6 squares away from a lens with focal length of 4. Okay, so this is an example where I get a real image that ends up a little bit bigger, right, actually twice as big, and farther away from the lens than the object was. But still a real image projected on the other side of the lens and upside down. Okay, so one more example, and I'm going to try and go through this quickly. And you don't have to watch me draw all the rays and stuff for this one. So I have an object height of 3, focal length of 4, first ray goes in parallel, out through F2, second ray in through F1, out parallel, third ray straight through the center, meets right there. You'll notice from this particular example, the image ends up being the same size, it's inverted, and it's real. When the object is exactly 2 focal lengths from the lens, the image ends up being the exact same size. Okay, so let's look at these 3 different areas. Right, I'll just put this up here and have you guys just pause the video and look at it for as much as you want. Okay, so anywhere between 1 focal length and 2 focal lengths away. So the focal length is 4, here's 8 squares, so anywhere between this 4 and 8, I get an image that's inverted and magnified. Right, so the object started out as 3 squares, the image is 6 squares, meaning it's magnified by a factor of 2. The green one out here, anywhere beyond 2 focal lengths away, the image is smaller, inverted, and so the magnification is less than 1. Right? The image is 2 squares, the object was 3 squares, so the magnification is 2/3. At exactly 2 focal lengths away, I get an image that's the same distance, same height, magnification of 1. And then just to look again at this one, the only other image that there is you can make a virtual image if the object is within 1 focal length. Anything inside 1 focal length is virtual and magnified.